So, hello everyone, welcome back. And we continue with our large language model workshop series. And every week we have been working with different topics. And so we have gone from Hugging Face models, showing how to work with them, and then local installation of large language models like Olama. And last week, we saw a little bit about LangChain, how to send requests for a large language model and have control on the format. So today, we're going to look at the Phi-3 large small language model by Microsoft. And today we will do also an exercise using a Jupyter notebook, and that will be taken care by Enrique Noriega. So, so these are the notes for today. You will find them in the chat. Okay, so we have been talking about large language models, and today we want to talk about small language models. So what are those type of models? You will find a presentation here. I'm going to follow it, and if you click on it, you will get this one. And so let's start. Okay, so what is Phi-3 and what is a small language model? It's another type of model, but with less parameters to tune, and also it's more focused on specific topics. So you have a trade-off going from generic, where you have less governed model, to something that you can govern and also specialize on specific tasks. So these are the family of small language models. And there's some advantages and disadvantages from using the small language models. For example, in the large language models, you have a system that understands almost all the texts and instructions, but and it's also versatile, and also has to do some you do some contextual relevance, because it has all these vector spaces where they can find all the different topics clustered around specific domain. Compared with the small language models, then you have a more efficient resource utilization. It's suitable for smaller data sets, and also is faster to train it. And the drawbacks will be that it has some limited language understanding, also some contextual limitations, and also is only good for task-specific training. It requires less computational resources, so so there's going to be some advantages. You will see that there are other options for small language models coming from other companies like Meta Llama 3 and Google Gemma, and also Mixtral, and even Apple has it Open ELM. And you can see now that the number of parameters are smaller. We have been seeing an order of 50 billion parameters. These are smaller, only have 8 billion, 7 billion parameters. And so they are more easy to handle. And also what makes these small language models attractive is that they are accessible and affordable. They have more efficiency in energy consumption. They're easy to customize, cheaper to develop, and also you can use it for different educational purposes. So being more accessible means that you can run it in your laptops, or you don't require a large amount of GPUs. And these are basically the main characteristics. They're accessible, efficient, energy-wise. They can focus on some tasks. You can reduce the number of hallucinations. They are more eco-friendly since they don't consume too much energy and cost-effective. And some potential application for the small language models in technology and services. Well, you can install these models on smartphones or smart home devices, wearable technology, automotive systems, educational tools, and entertainment systems. So these are some of the advantages of the small language models. So in the case of Phi-3, which is a collection of small language models developed by Microsoft, they have the key characteristics being compact, efficient, and high performance, as we just mentioned. And also Microsoft has a series of small language models, Phi-3, so you can find the Phi-3 Mini, the Phi-3 dedicated to vision, the Phi-3 Small, the Phi-3 Medium. These are the number of billion of parameters needed, and also you can find a mixture of experts. So you can have different small language models from Microsoft to do specific tasks in specific domains, like vision or text or a combination of both. And these models are open source, so you can have access to the source code and also make some adaptations because they follow the MIT license. Some other key characteristics: compact size, efficiency, performance. We already knew that. And also, they are good for working in natural language processing. And there are some advantages: being accessible. It works on almost all the smaller devices and older smartphones. It can have, they are cost effective, so they are more affordable than other large language models, and they have a reduced environmental impact, since we know that every request or query to a large language model is always associated with a big energy consumption. Some disadvantages: well, you have to balance. So these small language models struggle with doing complex tasks, like writing intricate stories, similar to a math-focused student who finds challenging to write an essay. Also, they are data efficiency-wise, so they are trained with small, limited amounts of data. So you have to have a trade-off. And the type of tasks that Phi-3 can be applied to, like text summarization, questioning, answering, text classification, machine translation, and sentiment analysis. So those are tasks that are done in natural language processing. Another thing that Phi-3 can be used on is for code development. So in code development, can help you with code documentation, code search, code review, bug reporting, and also save you time by automating tasks. And but it may struggle with complex code, leading to incorrect suggestions. So you still have to have a human in the loop. Okay, so Phi-3 can be combined with other large language models or to be and tools to be combined. So that's more or less what is Phi-3. And you will find different learning resources by Microsoft, like the blog, the portal. There is a cookbook, and also you will find all the model cards in Hugging Face for the Phi-3.5 latest version of families of Phi-3 by Microsoft. Okay, so let's go back to our notes, and next I will hand the microphone to Enrique. where he's going to be working with a Jupyter notebook. So let me stop my share. And hi, Enrique. Welcome.
Hello. Thank you.
Okay. And so you will find the notebook in the bullet point number 6, and which is this one. I'm gonna post it. Yeah. Okay.
Great. Thanks. So one of the applications of smaller language models, small LLMs or SLMs or however you want to call them, it's kind of a blurry line. But one of the cool things that you can do is run them easily in your local computers for some interesting applications. So what we're going to do today is that we are going to use Phi-3 as a coding assistant to help us build a web application from scratch by virtually not writing any code. You will not be able to get around having to correct some stuff, but we'll see some of the nuances. So Phi is a model that was trained with being a coding assistant in mind by Microsoft. So we don't really know for sure, but I suspect that this is behind the GitHub Copilot. Initially, they were using OpenAI's Codex model, but then they moved to something else, and they won't tell you what it is. But I think that this is the foundation technology for it. So I thought that this could be a good showcase of what you can do with it. Since we're making emphasis on a running locally, we're going to be using Llama. So Llama, we already had a session about it, but the summary about it is that it is a software package that allows you to run LLMs locally on your computer, accelerated with whatever GPU, CPU, or hardware you have, and interface with it using Python or LangChain or anything else. So the first step is going to be that you need to have it installed. If you need help with this, you can refer to the session that we had a few weeks ago about it, or to the website. There's going to be a link here, and you can follow the instructions. It's very simple as long as you're experienced running software, third-party software. And if you're here, you most likely are. So then you'll have to start Llama as a server. And here I'm just copying the command. I already have it running on my computer. Excuse me. So I'm not gonna run it. But for the rest of the notebook, we're going to be using Python, and we're going to be using the Llama library. So it has its own client. So you'll have to install it. If you don't have it, it's just pip install Llama. So once we have our environment set up, the first thing that we gotta do is that we have to download Phi-3. So in here, as Carlos was mentioning, there's a spectrum of different sizes. I decided to use the 14 billionth because this is the largest one that I can comfortably feed on my computer and gives the best results. So the larger the model, the best the quality of the results that you get. But you know, like there's a certain point in which you cannot run locally anymore. So here, Phi-3, 14 billion. Like if you want to run the 7 billion, you just want to change it. If you want to run the 3.8, you just need to go to the Llama website, and they have a list of the different tags just updated here accordingly. Since I already had it, the result is success because we didn't have to wait anything. But we do need to make a test call. I always like to do this to make sure that I did it correctly. What we're gonna do here is using the Llama client. We're going to use a chat call and specify explicitly that we're using Phi-3 and ask for a test message. This is the first time that I'm running Llama since I started this Jupyter environment. So it took a little bit to respond, but here it is. So we are sending, if you remember from the last session, the standard in the conversations is that it's a round of messages in which we're alternating between user and assistant. So user is us, assistant is a reply from the LLM. So my first question is, who are you and what can you do? And it's an AI developed by Microsoft, designed to assist on a wider range of tasks. This is what Carlos was saying. So this is built as a foundational tool for Microsoft technology to integrate their AI with Copilot and whatnot. So here, as a response, we get a message, which is the assistant message. We're just looking at content. But in addition to the contents, each Olama response comes with more metadata, so we can take a look at it. We can see what is the name of the model that generated this message. We have a timestamp. This is the actual message with its role assistant and its content. There's a stop reason. Sometimes it fails. Sometimes it just stops writing. So usually, if everything goes well, you want to see here stop. It tells you how many milliseconds it took to run, how much of that it took loading the model. So as you can see, most of it was loading the model because we just started. We did a cold start of calling Phi-3. How many tokens were on the prompt? 18. How many time it spent evaluating the prompt in the second? How many tokens were generated? 96, and the timestamp. So that is the basics, but we want to do something useful with it, right? So I created a small chat function utility that we're going to be using as the foundation of the rest of this notebook demonstration. So in here, we're just defining a function called chat that is going to take a message, and it's going to take a history argument. So the history is, as its name say, all the messages that were sent before, and we want to keep using them for context throughout the conversation. We're going to also specify a model with a default value of Phi-3 14 billion, and it's not going to return anything. It's just going to print it on the notebook for us to see. So what it's going to do is that it's going to take that string and it's going to append it to the history to the end, because that's the latest round of the conversation. Since this is a user-provided message, its role is user as well, and we're going to use the Olama client to call the chat function with those specific parameters. Something really important, a really important observation is that we're setting some options to the model, and here we're setting temperature to 0. What that means is that no matter how many times we call it, if temperature is 0, we're going to get the same response always. If we increase the temperature, we're going to get slighter variation. So we can start with a different word, but the closer it is to 1, we can get a completely different message. Hopefully it's still on topic, but in here we care about replicability. So we don't want to get variations. We want consistency. So we set the temperature to 0. The other option is that we want string true. Well, what this means is that when we call the LLM, we get the output as it's being generated. So we get the first word, and then it's going to take a little bit longer for the LLM to generate the rest of the words. But we get one by one, and then we can print it as soon as it's coming. That's just like a user-friendly option, but it doesn't really have a lot of impact on it. So we get this. We get the output of the LLM. We're going to call it a stream because of what I just mentioned. And then we're going to iterate through the stream to get the chunks. So the chunks are just the specific words that we get one by one as they're trickling down. And once they are done, once we get them, we create a new message, and we get the role, and we just concatenate all the chunks together. So we're going to execute this. So this is the most technical that we're going to get here. We're just going to repeat using this function to see how we can code without writing code. So the first thing that we need to do is that we need to set a role for the LLM. We use the system message for that, and we're going to specify that Phi-3 is a coding assistant that helps a software developer. In that case, we are the software developer. We want our responses to be concise, and we don't want any extra explanation outside of the code. I don't want the explanation of the code. I just want the code. You may add comments to the code, but let's keep them brief, because I found that if you don't specify that, it's going to be very verbose with the comments. So we do not get an explanation outside of the code, but we get it within the code. We don't really want that. So the code should be self-explainable, and we can sprinkle a comment here and there just to make it more user-friendly or clear. But by reading the code, it should be enough. So this is the system message. So we are setting the role of the LLM. And the first thing that we want to ask the LLM to do, or small language model, is to tell it that we're going to create together a REST API application to maintain a database of a catalog of books. I will describe those requirements, and you will be, by you I mean the LLM, Phi-3 is going to be in charge of the details. This application will be primarily built using Python, FastAPI, and SQL Alchemy. So those are standard Python libraries used to build web applications and interface with databases. The first thing that you need to do, Phi, is to define the directory structure of that application. So calling our chat utility function, we're gonna ask Phi, and once it finishes, we're gonna print the results, the last element of the history, as marked down here. So this is the output of that prompt. And you can see here that this is not Python by itself, but this reflects what is the directory structure of the API, of the book catalog. So an API directory, we have a directory called app that has standard Python boilerplate, like this defines it as being a Python module. We have file that contains the database code, crew.py. These are the web API operations. They're called CRUD because that means create, request, update, and delete. And schemas are just the format of the messages that will go back and forth between the client and the server. So this is standard software developer lingo. We also get the tests application or directory where we'll have some unit tests for the web API code and for the schemas. We'll have an entry point to run the actual server application, and we'll have a hidden file that contains the environment variables. So far, Phi hasn't given us code, but it has explained to us how we can start to route down the individual components. So based on this directory structure, we'll start with the database models. So be patient with me. I'm going to overload the meaning of models, of the word models. From now on, models is just going to be database tables. Let's ask Phi to generate the source code with database models. So we are querying in English. Write down the contents for the model files, and those contents should include the models for the users and the books in the catalog. We're going to pass the history just to keep the context of the conversation, and let's see what we get out of Phi. You're going to see throughout this demo that each time that we ask it something new, it takes longer, and I'm going to explain you why in a bit. So here's the first response. You can see how it is filling the db/models.py file that if I scroll up a little bit here, was defined within app. So you need to be aware that it's not going to match perfectly. You need to supervise the output and make finer adjustments, but the bulk of the work is going to be done for you by Phi. So here, the contents of this file contains SQL Alchemy code. So It's not really important to get into the meanings of this, but this is from my experience, this is correct. So we're like getting the actual building blocks of database applications, like the columns, the data types. We're getting a relationship between tables, most likely to connect the user and the books. And we have a base class. So it is important here to note how it's importing a base class, a custom base class that is not defined anywhere. So it is hallucinating it. This is simple to fix. This should be SQL Alchemy base, I think, but you'll need to pay attention to it. Setting that aside, there are two classes. The first one is the user class. We requested explicitly one, and it's the specifying a table name for it, users, and it's adding fields to that table. The first one is a primary. So this should be primary key, not primary EIDT. So be aware of that. ID, the username of string type, an email of string type, and the books. So the books are defined as a relationship. This is a foreign key, basically. This is the other end of the foreign key. The second class is the book model. The underlying table name for book is books, and similarly, it has an ID, which is a primary key that has to be edited. Its title field, its author field, and its user ID. So we're not getting the contents, but it doesn't matter because this is just a catalog. This is not the actual database with the contents of the book. And you can see how the user ID, like there's a relation between the user model and the book model. Here, this, like, if you're familiar with databases, there's going to be books associated with multiple books associated with a user, but each book is going to be associated with a user only once. This is just a sign choice made by Phi, but it's pretty much standard. And the way it is linked, the way both models are linked are by using a foreign key. So the foreign key is imperatively defined on the book model, and then on the user there's a dynamic field. So if you've developed something with SQL Alchemy or any other object relationship manager library, this is pretty much a standard. So this is relatively accurate, but it still needs to be verified. And these are some of the small details that I mentioned. So I say it took me 90% through the street by building this file. But we still want to do some more. So let's ask Phi to edit this file to include a movie reviews. So I want to give a comment. As a user, I want to give a comment about for one of those books. So I'm gonna ask it to create a new model for book reviews. Now we're gonna have 3 files. I just wanted the class for it. I don't want Phi to repeat user or books again. So it's gonna do something similar here. It creates a new SQL Alchemy model, book review. It has a table name. It has a rating. Well, I think that was good. So out of 5.0, nothing is stopping us of doing it from a scale of 1 to 100. There's a review field, which is string, and a book ID, which is a foreign key to the book itself. So we need to do some extra work here if we want to link the book model to the book review using a back relationship similarly to the user and book model. But just for sake of the demonstration, you can see how you can request code out of Phi by using English or any natural language. You get the actual code. So let's just call it a day with the models. Let's move on to what is next. So what else do we need out of it? So once we have the models, so this is interfacing with the database, storing the data, but we actually want the pipes through which our web client applications are going to speak to the database. For that, we're going to use a REST API, and we need to remember that we are requesting Phi to use the Fast API framework. So let's ask Phi-3 to write down the contents of the file name app/CRUD. And let's emphasize to remember to use Fast API and to add endpoints for each of the models in this app. So this is important. Each of the models is not spelling individually all of them. We are just referring through an operand to previous elements in the conversation. So this being a language model with conversational capabilities should be able to pick it up, but let's see what happens. So now, since we're extending the history of the conversation, each time we request something, it may take longer because it's reading more background information. But let's see what we have with app/cur.py. We are getting, okay, importing fast API construct. So this is correct. This is a dependency injection mechanism. This is correct as well. So this is real nice. So we have the model file from which we import user, book, and book review. So Phi was able to pick up the individual models out of the file without us having to explicitly say it. And is creating some schemas. We haven't gotten into that, so these are hallucinated. Nonetheless, that they might be correct. So we'll get to it at some point. So we want to create a user, update the user, read the user, and similarly for each of the other models. So book review and book. And then this is a function that was hallucinated, but this is the standard way that you did with Fast API. So I see why it did it. So what it's going to be doing here is that it's creating the scaffolding Fast API functions to do the create, update, and read operations for just one model. So let's just walk through it. Create user takes a user instance, which comes from the schema. So you can see that user create. So that pretty much means if you're a web application or a client application that are calling this function from a REST API, you should use the fields that are within user create. So this is accurate. We are getting a database through dependency injection. So you can take my word for it right now, but this is the way that the Fast API documentation tells you to do it. So far, so good. Unfortunately, we don't have the getDB implementation yet, but it doesn't matter because we can ask Phi-3 to write it for us. And then once it does that, it is asking this user create schema to be written down to the database. I'm not sure if this is right, but conceptually is. So you can see how it is repeating. Oh, yeah. This decorator is just setting what is the endpoint of the API. So the endpoint is users. So we're going to post or pass the user, but maybe we want to update a user using the put method. This is accurate as well. We need to specify what is the user ID. So far, so good. But this mirrors the operation above, but just by changing the verb. So we're updating the user and we're reading the information here. So to read something, what we want to do is that we want to get the user ID, which is the key, and then use the database to fetch it. So this is conceptually accurate, but look at this. Repeat the above pattern for book and book review models with the appropriate endpoints. So this is rather bare bones, but Phi is being lazy here. So I am the lazy guy. I'm the developer. No offense, but I want AI to do the hard work for me. So we're not gonna let Phi to get away with this. We need to insist. So we need to command it to finish the job, and we can just do that with another message. Extend the previous script to include the CRUD operations for the other models. So let's see what happens here. So it's taking a little bit. I take that it was offended a little bit because I am asking it to do more work, but whatever. So now it's giving us the same thing for the book model. So book create, book update, and read book, but it's still being lazy. So it's stubborn. We need to insist. So you're missing the book reviews model. We can just say it, and it'll do it. Um, all right. So okay. So now it's not printing the other models, but it's referring to them. I I mean, yes. Apparently, Phi is a little bit lazy in that sense, but we're getting what we want out of it, right? So we get the book create operations, the create, update, and read operations. There's no read construct. We could request it, but let's move on because it's become rather tedious. So we have the endpoints of the API, but we need the schema classes. So the schema are the parameters that are going to govern how the client applications, so that could be a web app, phone app, or a desktop app, all these REST API. And we use Pydantic for that. This is standard Python library. Well, it's not a standard, but it's customary for this type of applications. So let's just ask it to read it. Okay, so let's take a look. We're importing the Pydantic base model. That is correct. Some typing classes were importing the database models. That is correct as well. So for user create, we request a username and an email address. For updating it, we request it too. And to read, we're requesting the ID as well. So repeat the above pattern for book and book review. Yeah, yeah. So you know how Phi behaves. So we're gonna ask for it. And let's see. Okay, book update, book review, create, and book review update. So for the book create, we just have title and author. We could add, we could explicitly ask to add, what is the title of the book? I'm sorry, the creation date of the book or the publishing date of the book. Mm, what's in, I don't know, a summary or whatever. You can do that through prompting as well. But you can see here, how we're getting pieces of the application, and we're not even getting complete files, but it should become fairly easy for us to just piece everything together. Uh, Most of this is not duplicated. It is redundant in the sense that creating a database application has some redundancy, but it's not really being um, overly verbose. So the schemas are out of the way. So what if we want to do some unit tests? So remember we have the endpoints of Fast API. Let's just ask it. And as I mentioned, observe how each time I ask something, it's taking a little bit longer. Oh, excuse me. It is because we are appending an extra message each time, so it's reading the whole thing. So we're using PyTest for it, and it's telling us to fill the test underscore crude application. So this is test client is a file from Fast API, a class from Fast API that allows us to call the endpoints without actually having to spin up a server. So this is good. So this is just giving us scaffolding. So these are the tests, but I want Phi to fill them. So by now it's established that Phi is a little bit lazy. We need to push it around, but when we insist enough, it's gonna give us what we want. So we ask it to regenerate the file, fill in the details of the tests. So now they should have some content as well. Oh boy, this one is taking longer. So the reason, oh, okay. All right, so let's see. So this is where I wanted to get to. We are, and maybe I couldn't write it this way, but I guess that it is valid. Like we are parameterizing what is a method. I could add a separate function for it, but that's just my style. Um, we're actually calling the HTTP verb operation from the client, depending on what is the method that we get. And we are passing some specific input data based on schema. So this is great because it's being consistent with what we specified before, and we're expecting a specific status code. So I'm not sure exactly of what is the difference between 201 and 204, but I know enough to tell you that as long as you're in the 200s, you're good. If you're in the 500s, then there was an error. So these tests, what they're doing is that they're filling in stuff to the database, and the Fast API framework should return an HTTP response that has this specific status codes assigned. Because if there was a mistake, there would be a 500. So that's where it would raise an exception and fail the test. So it repeats the same for the books, and it repeats same for the book reviews. So these annotations are the way that PyTest parameterizes this specific input. So what it's going to do in the end is that it's going to call this function 3 times by changing the value of method to post, put, and get. So this is just a way to reduce the boilerplate a little bit. And this is much closer to what we want to get. So there may be some details, like maybe you want to add a test that is designed to actually make it fail because you don't want it to pass, like if you pass some invalid inputs or something like that. But the LLM cannot guess that. So it's up to you to elaborate and get more results. But I think that so far this is an almost complete example. It's up to us to finish the details to make the corrections of the adjustments. But we have basically all the business logic there. We have all the input or the data formats. We have the database models. We need a starting point. So let's ask Phi to create a main.py script that is going to be the entry point. And that script runs a web application using Uvicorn. Uvicorn is a Python server that is frequently used to run Fast API applications in production mode, because you can run in debug mode. We don't want that. We want the production mode. And we want to allow parameterization of those parameters, the Uvicorn parameters, from the command line. So let's just ask Phi for that. I hope that it doesn't take too long to reply. But where I was wanting to mention is that the LLMs, being transformer neural networks, have an input window size. So you can pass a sequence that has 5 words, 10 words, 20 words. But the self-attention mechanism between those is quadratic in nature. So the longer it is, the longer it takes, because if you have five words, 5 input words, each of those is going to pay attention to the other 4 words. If you have 10, then you have 10 multiplied 10 times. If you have 100, then you have 100 words that look at other 99 words and to itself as well. So you can see how this flows up. Since we have a conversation with multiple rounds, all of it is serialized in single long input message. And you can see how The longer the conversation goes, the longer it's going to take for it to reply. But let's see the result. So we're going to use we ask it not to explain something, so it's being stubborn against our instructions. But like at this point, if we have lemons, let's do lemonade. So import unicorn, use fast API. We're importing the app class from the app directory. This is not defined, so it's up to us to fill the details. But we are going to create an argument parser. We explicitly requested this. We want to get the arguments of the command line. This is standard Python. Usually the arguments that you define are that you want the host name and the port, and these are reasonable defaults. Then we want to config unicorn. This looks reasonable. I'm not sure if it's correct. Then we want to start the server with unicorn run. We're specifying the port and the host for the command line. We're specifying the config. And finally, this is just like, this is where the Python file ends. And this is how we would run it from the command line. So far so good. You need to weed out these instructions out of it, but they're informative nonetheless. And finally, we'd like to make this cloud ready. We can create a container image to deploy our application on AWS, Azure, Google Cloud, or Cybers, or any other cloud. So let's do that using Docker. Let's ask Phi to generate a Docker file that builds and runs this application. We deployed. We're specifying Azure, but let's see what we get out of it. So we should get the contents of a Docker file now. Yep. This one I think is going to take a little bit longer, but it'll finish the example, and then we'll have a complete application built end to end using an LLM coding in English, which is pretty sleek in my opinion. This won't replace developers because, as you see, you still need to know what you're doing in order to fix the mistakes and the idiosyncrasies that the LLM cannot get or guess out of you, because it's impossible to be overly specific or to, with telepathically tell the LLM what are your intentions. So when I ran this before, it gave me the Docker file, but then it started straying out with additional stuff that we didn't request. Let's see if it happens again. It should, because temperature is 0, but like sometimes unexpected stuff happens. But while it finishes, if you have any questions, please feel free to ask. So something important to take in mind is that we're using Phi-3. You could use a smaller model, but in my experience, when I was preparing the notebook, if you want to use the smallest one, that is the fastest, you couldn't get good quality code out of it. So you need to be aware of that trade-off. Also, if you're using another LLM, say if you use Llama 3.2, you might get as good results as with Phi. So Phi is not the only one that writes code. And the tendency is that, or the trend is that the LLMs are trained for everything. So there's even specialized stuff gets superseded by the latest LLM that comes out. So if Mistral V 0.4 comes out tomorrow, I bet it's going to be great. If Llama 4 comes out or GPT-5 comes out, it's going to be great writing code as well, because they have already seen stuff. They know what is fast API, Pydantic. You could code JavaScript, so they support basically any mainstream language, and you can just customize its behavior through prompting. So it is taking too long. It is going to come back at some point. But I bet that what we're going to see is it's a super long output that the beginning of it is going to be correct, but then it's going to start leaking some training data. There we go. All right, so we are inheriting a Docker file definition. We're setting the work directory. We're running the apt-get command installed. Inside the requirements file, we didn't actually ask for it, but we can ask Phi to generate the requirements.txt file. Installing fast API, copying the files. So I'm not sure. For example, here, this is third time that we see a word here. It's not necessary to do it multiple times. So it's repeating itself. This is where I mentioned you need to pay attention to what's going on here. So basically, repeated its contents 3 times before giving us the running instructions. So this last message didn't work very well. And I think that we've reached the limits of the length of the conversation. So final remarks, like you can avoid this, but you need to be clever about it. You cannot grow the conversation as long as you want. You need to be smart about summarizing stuff or taking out prompts or then just replacing prompt for starting a new conversation with the relevant context included in the first prompt, such that you get quick responses with the actual decisions that you did. Because, we're looking at multiple definitions of the models, of the model file. We want to put it all together, reduce the duplication, reduce the number of tokens, and it will be more accurate. But here you can see that it starts straying to stuff like what is the area of a circle? We didn't ask for it. Then this is a bug basically. So if we change this to llama 3, probably it wouldn't happen, but llama 3 is larger. But yeah, so this exemplifies how you should be careful and always verify what you get. But this finishes the example. And yeah, we finally bootstrapped an application using Phi-3. You can use these to write your iOS applications, Android applications, React Native applications, wherever you have in mind. So let me see. There are some comments in the chat. Stubbornness Phi-3 when you're running code is similar to what used to happen with GPT 3.5. So I guess it makes sense. Microsoft is catching up to GPT in that sense. So probably with Phi-4, this will be improved. Is this running a CPU? It's running. So I have a Mac, M2 Max Mac. So it's faster than the CPU, but it's not as fast as with a proper GPU. If I had a 3090, this will be much faster than that. There are some laptops that have an NPU. So this is something relatively new. I do not think that Llama or a like Hugging Face already support the NPUs out of AMD and Intel, but I bet that that's going to happen soon. As a matter of fact, I was reading a blog post today in which they released a new version of Llama 3.2 point whatever, and they say that they support ARM and NPUs. So I expect the industry to follow that lead. It may be possible to transfer training between these Phi-3 models using Translora. Nice. Thank you for sharing that link. I'll take a look. Yeah, so I hope this was fun. And that is the end of the demonstration. So hope to see you next week here as well. Thank you for your comments and for your pointers.